Guys, when you listen to me, guys, before I do problem sheet 10, let me give you, this is quiz 4 for next week. I know you may not have looked at it, but this is a little bit tricky, so I want to give you a hint. This is quiz 4, which is due next Tuesday, so in a week time. The problem is, I want to give you a hint for doing quiz 4. Right? If you read it, it says that there are n functioning systems, and the n has a geometric distribution with this PMF, and each system is made up of alpha parallel units, and the lifetime of the parallel units are Zi1 to Zi alpha. So that means if yi denotes the lifetime of system I, right, then this would be equal to the maximum right. You guys follow what I'm saying, guys? Because they are working in parallel, working in parallel means that the ith system will fail if all of the units fail. So the lifetime is the maximum of Zi1 to Zi alpha. Now x is the lifetime of the x here. If you read the last line here, x is denotes the time to failure of the first out of the n functioning systems. In other words, x is equal to the minimum. X is equal to the minimum of y1, y2 to yn. All right, and the question is to find the var. The question is to find the value at rest of x. So what you need to do is you need to do a couple of things. First is to derive derive the CDF of x. What was wrong with this pen? You need to derive the CDF of x, and then then set this equal to q and solve for x, right? And that x okay, that x will be the var at q. Okay, all right, guys. You follow what I'm saying? So this is what you need to do. I have, sorry, I think maybe it's too large. I have given you as much hint as possible. So the hint that you need, this is the hint I give you to do quiz 4, which is due in 1 week time. So you should work out yi as the maximum of zi1 to zi alpha, and x as the minimum of y1 to yn. And the first thing you must do is to derive the CDF of x, and then you solve this equation to solve for x, and whatever the solution that you get will be the value at rest. Okay, guys. So try doing that. And this question is a little bit tricky. So try doing it. If you cannot do it, come back and see me. If you still have difficulties, after this hint, please come and see me, or please email me. Right? Okay. All right, guys. So are you guys okay or what? Can you now start working on quiz, not quiz, the problem sheet 10. So I'll put this here. If anybody wants to look at this, you can look at it. So this is the hint for doing okay, guys, can you start doing question 1, please? Question 1 on sheet 10. I will give you a couple of minutes to do question 1. Where's the assignments? You signed it? Yeah. Thank you for stopping.
So that's to be
Can you do the first question, please, as soon as you can? Then I will show you how to do it. Let me show you how to do question 1 then. Maybe you can do that just by yourself. All right. Now you may know from the last tutorial. You guys were here, right? The last tutorial. from sheet 6, you probably, I mean, we did sheet 6 in the last tutorial, right? You probably remember that for the exponential distribution, the var is equal to minus 1 over yes, and the ES is equal to minus P lambda in the bottom, and in the top you have P minus, correct me if I'm wrong, minus P minus all right. Is it, we got this in the last tutorial, is that right? If you look back in the stuff we did last Tuesday, you will see these, right? Now from statistical methods, math 20802, the ML estimate for lambda, I think I mentioned this some time ago. What's the ML estimate for lambda? Is 1 divided by x bar, alright? I mean, if you don't know how to derive this, I mean, I think if you haven't taken my course, statistical methods, you can look at the link I sent to you on Sunday. Okay, so the ML is so the ML is for var and ES are as follows. So all you have to do, guys, is to replace lambda by lambda hat. So you get this as the estimator for var, and you get this okay. So that's question 1, guys. It's pretty straightforward, right? All you have to do is to find the MLE for lambda, which we know from this course. We know that MLE for lambda is 1 divided by the sample mean, alright? And once you know the MLE for lambda, you just simply replace lambda by the MLE, right? To get this and this, okay? Alright, guys, can you do the next one, please? Question 2 on sheet number 10, which is on finding the power function thing. Yeah, the power function. This is clear to all of you guys. Any questions on this? Are you guys okay with that? Yeah, okay. Switch off.
I didn't go into it.
I forgot one.
Oh, right, so you can go. So,
I'll bring one next week.
I thought you hadn't given out yet. Hopefully you had it today.
Next week I'll bring chocolate for you. You do question 2, please, now, guys. Guys, from the lectures we know that we covered this distribution number 2, the power function distribution in the lectures, and we computed the VAR to be equal to this, right? So the expected shortfall will be this, right? And if you do the integration, this is what you get, and after simplification you will get this, right? So this is the formula for the expected shortfall, and this is the formula for VAR. We derived this formula in the lecture notes. I mean, in the handwritten notes. I mean, okay. And we also showed from lectures, you may remember, the MLE of A. You should look back in your handwritten notes, or the one I put online. You will see it is equal to minus n divided by the sum okay. This is, do you remember this formula? Yes. Okay. So hence the MLEs for the VAR and ES are as follows. So the MLE for VAR will be the following. Okay, and the MLE for ES will be the following. Just a minute, give me 1 second. Okay, so these are the answers for question. So these are the answers for question number 2. Right? Okay, so it's clear to any questions you guys have on this. And you do the next one, please. Question 3. Question 3. Right, guys. Okay, question 3 is something we did in the class, so you should know what it is. I mean, question 3. You should look back in the notes I gave you. The formula for var is, you may remember, is mu plus sigma times phi inverse of p. Okay, and the formula for ES, if you look back in the notes, you will see is mu plus sigma divided by p okay. Do you remember these formulas? I did this in the class a while ago, maybe this week or last week, I can't remember. You should just look back. I mean, from statistical methods, the MLEs of mu and sigma are, mu hat is the sample mean, yeah, and the sigma hat is the square root of 1 over n okay. Alright, guys, so these are the, so if you look back in the link I gave you on Sunday, you will see how to prove that these are the MLAs for mu and sigma respectively. Right? So hence so the MLAs for var and ES are as follows. So for var, the MLA will be mu hat plus sigma hat. Okay, and for ES, the MLA will be mu hat plus sigma hat divided by p. Okay, so that completes question number 3. All right, guys, any questions on this? Are you okay with this? I mean, we derived the top 2 formulas in the notes, in the handwritten notes. So you just please make sure you know, they should be online, so you should be able to see them. And from statistical methods, from the notes the link I gave you, you can prove that the MLE for mu and sigma are x bar. X bar is the MLE for mu, and for sigma this is the MLE. Okay, so alright, guys, can you do the next one, please? Unless you have some questions. Okay, that's. You find the knots. Did you find it? No, it's somebody. This is. This is Wikipedia, is it? I meant my handwritten notes. I meant my notes that I gave you during the classes. When you go to the course website, I show you that this. Then you can find like this. It should be in the, I don't know which one, but it should be in the handwritten notes. We look through these notes here. These are the handwritten notes. They should be in one of them. It should be, I don't know which one. It should be the last. It should be the last two. Yeah. Yes, okay. You okay? Where is it? You okay? This one. Log normal. LN stands for log normal, yeah. Yeah, that's right, yeah. No, that may be true, yeah, it is true, yeah. Yeah, it is true. Yeah, it is true. How is it? Okay? Okay. Are you guys okay? Yes. What's the problem, sir?
You have to leave things like that.
Yeah, you can. If you want, you can replace it. You can replace them. Yeah, so in place of new hat, you can say it's for and this. Yeah, this. You find it. No, that's the podcast. No, I mean the handbook. This it should be one of. You don't need to come here. Oh, no. Is it for you too?
I'll try now.
Okay, that's it. Yeah. Okay, guys, have you done the next question? The next question is on LN. LN stands for log normal, right? So, is it question 3 or done just now? Question 4. Hello, guys. Hello, guys. The CDF of this, do you know the CDF of the log normal is is this. Right now, to find var, do you guys know how? To find value of rest, you need to set this equal to p and solve for x in terms of p. So you get so this implies that x right, and this implies that x is equal to exponential of mu plus sigma. So var, you guys listen please, the var is equal to E mu plus sigma. Alright, so this is the expression for var. The expression for ES remember the formula for ES is 1 over P times the integral from 0 to P of this one, which is E okay, and you can simplify a little bit. This will become this. So this is the formula for ES, and this is the formula for var. Now to find the estimates, you need to first find the ML estimates for mu and sigma. Now once again, let me put this here. Once again, if you've done math 20802, so just mention from math 20802, the ML estimates for mu and sigma are as follows. Mu hat is equal to 1 over n times the sum of log of xi, and sigma hat is 1 over n times the sum of log of xi minus mu hat squared, and you need to take the square root of the whole thing. Alright, so these are, if you've done this course before, you will see that these are the ML estimates for mu and sigma. So hence the maximum likelihood estimates for var and ES are as follows. So this, the MLE for var will be this is the MLE for var, and the MLE for ES will be the following. Okay. Are you guys okay? So did you follow what I've done, guys? Okay. I mean, I just did found the OR and the ES first, and then used the result from statistical methods course to find the MLEs. Okay. All right. Any questions, guys? No. Okay. Can you do the next one, please? Are you okay? Oh, you guys, are you okay? You look tired today. Can you do question 5, please? You guys okay? Can you find that thing on your okay, thank you. Okay. Yes, sorry. Yeah. There are 3 parameters mu. For the GEV, there are 3 parameters mu, sigma, and psi. Okay. And I estimate the psi parameter using these formulas. And these are non-parameters because it only assumes from the data. I mean, these involve only the data, and it doesn't assume anything about the distribution. Okay. Whereas for estimating mu and sigma, I'm using the MLEs. MLE, by definition, they assume a certain distribution before you. They assume the data follow certain distribution. Right, so the estimates for mu and sigma are parametric because there's the ML estimates, MLEs by definition assumes that the data follow a certain distribution. In this case, the GEV distribution. Yeah, they are parameters of GEV distribution. And psi is also parameter, but psi is estimated. Psi is estimated non-parametrically, whereas mu and sigma are estimated parametrically. So that's the difference between the two. What do you mean by analysis? You can, yeah, you can. Yes, you can use MLE to find this mu or psi. But in that case, that would be a parametric estimation, not a non-parametric estimation. But the formulas given here they are non-parametric estimators for psi, because they don't assume anything about the distribution of the data. That's why these two are non-parametric estimators. Whereas mu hat and sigma has a parametric estimation because they assume that the data follow the GEV distribution. You have any other questions? You have any other questions? Guys, what about you guys? Do you have any questions? Do you guys have questions? Do you have questions? Yeah. No, you can. Is this okay to leave it like this? Is it okay to do this?
Like the way I did it here.
It's okay to leave it like this. Guys, so can you do question 5 and 6 in your own time? And you can look up the solutions online. The whole solutions are on the first website. So if you let's start, you can look it up. And tonight I will send you your marks. I will send you your marks for the in-class test, right? I will send it tonight, maybe in 2 hours' time. I'm also tired. I'm very tired also.
你去听吗？我跟你说一下，这招人的。内推是吗？内推。
也按照。
本来就是香港美什么都见过。马尾的，我们小学时候就经常。哦，对，他累得要死，狗吃。
哎，不是，主要是咱们这专业不行。
咱们这专业不行，什么专业行啊？
是可以，他们要，他们要我们这专业干嘛？
他们要做算法，就做那个什么数据啊。
咱们帮他们算一个哇，